Welcome back. This is Module 1.3.8, Ecological Succession. Ecological succession is a process in which communities of plants and animal species are replaced over time by a series of different and often more complex communities until a stable climax community is reached. There are effectively two types of ecological succession. Primary succession, which is the establishment of biotic communities on essentially bare ground where there may not even be soil. It may be going from bare rock. Think of new volcanic islands such as the Hawaiian Islands or the Galapagos Islands. This is primary succession. You have lava, it breaks down. You have a pioneer community come in, maybe mosses, lichens, something like that, very primitive photosynthesizing organisms, and they actually change the rock into soil. As they die, their bodies put organic material into the soil, allowing other plants, at first simple herbs, and then perhaps as the soil increases and deepens, you can have shrubs and later even trees. And this is the process which gave rise to the vegetation of the Hawaiian Islands and the Galapagos Islands, for example. But it can start in all sorts of different places. Bare rock exposed by glaciers, volcanic islands, as I already talked about, even an abandoned parking lot. We can have what they say a new pond. You can have succession there of aquatic organisms as well. So there are many things. This primary succession takes a long time, as soil typically must be produced, and that pioneer community, the first organisms to live there, are very important, but they have a very small effect, so it takes a long time for this small effect to move primary succession along. Primary succession is not as common as secondary succession, the second type. This secondary succession occurs after there is a disturbance in an ecosystem that's already established. That's much more common. It can occur, for example, the disturbance can be humans farming an area and then they abandon the fields, or it can be a forest fire, or it could be a landslide, a hurricane, a flood. These kind of events all are disturbances which can kind of reset ecological succession. As an example, we're going to look at Glacier Bay in Alaska, and it's really a beautiful area. I've only been there on a cruise ship, and so I was well fed when I was there, but it's very beautiful and a very interesting area. So this actually shows a river of ice that comes down, so some of the soil that's pushed, and this is the ice that comes in, and we have icebergs that fall off and calve off of here. It's a very interesting process, just the glacier itself. But we're more concerned here about the aftermath of the glacier, where the glacier has come by. And so this shows exposed soil. It's essentially sterile. So there is inorganic soil there, small particles, but it lacks some of the nutrients and certainly the biological material that it needs. The first invaders of this site are lichens and mosses, and they are able to fix nitrogen, or that is, they take nitrogen from the air and turn it into nitrates and nitrites that are in the soil that plants can use as fertilizer. We can see a site that's 20 years older, 20 years later. We have small stunted trees, alder trees. They also are able to do this neat trick of fixing nitrogen. They have mutualistic bacteria that live on their roots, and they do this. And the alders form these very dense thickets. But the alder seedlings are shade intolerant. And it is only when later, when we have spruce trees that come, the spruce trees have seedlings that are shade tolerant, so they will replace themselves. And the climax community is a spruce forest here. And so that's a good example of, I guess, primary succession. An example of secondary succession could be following a volcanic eruption through an established ecosystem. Mount St. Helens erupted back in 1980. probably before most of you were born. Here we can see about 10 years after the eruption that there are pioneer species that are getting established. I'm not sure if this is a penstemon, this red flowered thing in the foreground. I don't think it's an epilobium, but anyway, it doesn't really matter that much. We can see that 12 years later that you're already seeing some Douglas fir trees, which be members of the climax community, and a lot of low herbs, but that's because there are already seeds in the soil from the mature Douglas fir trees that were there. That's why it's so rapid. Here we can see a figure of terrestrial primary succession starting from the left. Exposed rocks, and then lichens and mosses, a pioneer community. They form thicker soil. Then you get grasses, herbs, and maybe some shrubs, maybe some tree seedlings. Then you get a forest, and finally you get a mature forest, a climax community, which is self-reproducing. The first forest community typically is not self-reproducing. And I do want to call your attention to a disturbance event that occurred here in June of this summer. The Monument Fire was a historical event. It was huge in its proportion and devastating in its effect on some of the members of our community. But it's interesting from an ecological perspective to watch what will happen where we have burned areas, and already after the monsoon we see herbs and grasses growing back, and the wind pushed the fire through so quickly in some places that it may not have killed all the trees. I'm not certain. I'm not doing any research, and the forest is closed. Anyway, it's something interesting to keep an eye on as you continue your association with Sierra Vista, to see how the Huachuca Mountains recover from this disturbance which occurred in this summer. And that concludes this module as well as the topic of ecology. It also concludes Unit 1. And Exam 1 will cover science, life, chemistry, including inorganic and biochemistry, biological macromolecules, and then ecology, all the modules of ecology. And so study hard for that first exam.